question we have here says, in an electric circuit, an inductor of inductance zero point 0.5 Henry and resistance 50 ohms is connected to an alternating current source of frequency 60 Hz. Calculate the impedance of the circuit. So, to get started, we need to get the formula for impedance, which is Z equal to square root of R square plus XL square. Hello, no noise, please. Then, from the question, we have R, which is the resistance, to be 50 ohms. Then we have the inductance L to be zero point 0.5 H. What does H stands for?
H.
What does H stands for? When you say 0.5 H, what does it stand for?
That's the ohms.
That's what? Who is that one talking? If you are talking, let it be for this class. Yes.
L is 0.5.
I say, what is H?
What does H stand for? Listen. When I was reading the question, I mentioned it, but I purposely asked all of you to see whether you are concentrating.
Doctor.
H, doctor.
No. Listen. Sarah, what does H stands for? What's the meaning of H? Now listen. When I was reading, I said, in an electric circuit, an inductor of inductance 0.5 Henry. 0.5 what? Henry, yeah, that's the meaning of the H. So take.
Sorry, it's Henry of a name.
Yes, Henry of a name, okay? Is that clear?
Yes, sir.
So just take note so that you don't, when you see 0.5 H, you're like, what does it stand for? It's the unit of inductance. So let's continue. Please, all of you should concentrate because I just used that to test whether you are listening or not. And I found out that averagely you are just hearing me, but you're not actually listening. So I said we'll find the formula for impedance. Z is impedance, and that is R square plus XL square. That is the inductive capacitance. So with this, we have to find the XL because we're not given XL. But we've been given the frequency to be, from the question, we have 60 Hertz. Yeah, 60 Hertz. So XL equal to 2 pi FL. So with this, we can have 2 times pi, we don't give them which pi to use, but we're going to substitute pi later. So times the frequency, which is 60, then times 0.5. So if we multiply 2 times 2 times 60, that will be 120, then times 0.5. So this is going to give us 60 pi ohms, okay? 60 pi in ohms. Is that clear? Can you hear me?
Yes, sir.
Yes, it's going to give us 60 pi ohms. Now, the from the we can substitute this into the z equal to square root of you know r squared. The r is 50 all squared, then plus the 60 pi,
So you have a cutter.
60 pi squared.
Is it
Can you hear me? What is the value of pi?
22%?
Yeah, 22 over 7. So if you slot in all of this, let me know if you're able to get 195 ohms. That's what I got after multiplying all this. I used pi to be 22 over 7 into the square root. So let me know if you arrive at 195 ohms. Try it. Do you understand what I asked you to try? Do you understand what I asked you to try? Can you hear me?
Yes.
Can you hear me?
Wi-Fi is upstairs.
Okay, can you hear me now?
Yes, sir.
So I
So, can you
said
repeat what you said?
yes, I said pi is 22 over 7. So I slot in pi here and I multiply by 60, then I squared the whole thing, then I added it with 50 squared. And that gave me, I found the square root, that now gave me 195. So I'm saying you should try it and see if you get the 195.
Look,
Okay?
So I don't understand what you said. Your voice was
Substitute pi. Solve this and see if it give you this. Okay?
great. Okay.
Solve this and see if you get 195. Can you hear me?
Yes, sir.
So try it. But if you didn't get 195, then that means I have to do it. But I don't think I have to do it if you can just place in your pi, which is 22 over 7. So in some other questions, like I said, you will not only be given the inductance, but you'll be given both inductance and capacitance. And when you have such scenario, this is the formula for impedance. Okay? Take note of that as we move on. Is that clear now?
Yes, sir.
But we used this formula because we only have the inductance and no capacitance. So let me bring the next question, number 2. So look at this question and pick your correct answer. Yes. Who is picking the answer?
Who's picking answer?
Yes.
Is larger than that. Right is larger. X is larger. So like okay. X. It's really very larger. You know, picking the answer. I think it's good larger than X. Because so like the moon, basically the sun at the end and the moon at the end. So the moon is in the middle. Alright. I think it's A.
It says, which of the following statement correctly explains why a total eclipse will be seen by only by people on only a small portion of the earth? So it says, let me see if we can check it so that we can know which option is correct. Okay, let's bring the image here. Can you see this structure?
No.
Can you see this structure? Let me make it a little bit bigger. Can you see this?
Yes, sir.
Yes.
I want to resize it so
So
that
the
I can be
question complete.
a little bit. Okay, the question is not complete, right?
Yes, sir.
That place that is missing is why. It says why. Hold on.
Yes.
Let this be 400 and this be 200. So let's see. Oh, this is still resize this.
Please repeat your address.
Okay, 500 and so look at the image.
Yes,
These are the who are the people that are experiencing the eclipse? The people directly under the coverage. The people that
Moses is
directly.
one of them.
I said, who are the people that are experiencing the eclipse? Can you see this red circle?
Yes,
So those are the people that are directly under the coverage of the moon. Okay.
yes, sir.
Yeah. So those who are directly under the coverage of the moon, they are the ones experiencing the eclipse. So which of the option do you think is correct?
Look there and I'm Jordan. You are
Wait,
A.
A, right?
Yes,
Is
sir.
it? How can it be A? Look at the moon. Look at the
Right.
earth. Moon,
Then it's D then.
it's
Then it's
D.
D.
It's D,
First
okay?
yes.
You are right now. It's D. Is that clear?
Yes, sir.
So the moon, the Earth is larger in diameter than the moon, and because of that, these are because of the small diameter of the moon. So the people that will experience it will just be those people under the diameter of the moon. Okay, is that clear?
Yes, sir.
Okay, okay. So I'm going to show you something quickly in relation to this question. Let's see. Let's look at the solution to this question. The question says water waves have a wavelength of 3.6 cm and a speed of 18 cm per second in deep water. If the waves enter, if the waves enter a shallow water with wavelength 2.0 cm, calculate the speed of the waves in the shallow water. Now, there is something you need to take note of in this solution. Hold on. Something you need to take note of in this solution is that when a water wave travels from deep to shallow water, the frequency does not change. Okay? Frequency remain constant. Okay? Is that clear?
Yes, sir.
So frequency will remain constant across the
Yes.
deep and the shallow, water. So V equals to F lambda. F equals to V over lambda. So the first velocity is 18, and this is 3.6. So what is 18 divided by 3.6 to get a frequency? What will you get? Do that and tell me your answer. The frequency should be what? 5 hertz. Okay. Now you're looking for the speed. That's the velocity in shallow water you've been given. So now for the shallow water, V is F lambda. So F is constant. That is 5 times 2, which is 10 centimeters per second. Is that clear now?
Yes, sir.
Okay, so take note. The formula we had to use was just the V equals to F lambda. V equals to F lambda. So just remember that. Okay. Okay, let's look at this. Let's look at this next one and try to pick an answer. So consider this. A ray of light travels obliquely from a less dense medium to a denser medium. Which of the following statement is true about the light? So check it. Any one of you should come up with an answer. Yes, who is picking an answer? Moses, what do you think?
D, sir. D. D.
Sir,
Is it D for dog or B for baby?
D for dog.
D for dog. You said there's a change in the frequency of the light. Let's see. Light rays
Salad.
Light rays bend away from the normal when they travel from a denser medium to a less dense medium. Let's try to picture that. If we have something like this, one is representing glass and one is representing the air. So if this is a glass, let's assume that this is a glass, and there's a light ray across maybe the air and the glass, this way. So it's supposed to, let me try that again. It's supposed to follow that straight path, to continue on that straight path, but it won't continue on the straight path. It's going to be a normal somewhere here. Are you seeing this? And instead of continuing on the straight path, like following, let me see, instead of following this path, then I can reduce this. It won't follow that path of the yellow, okay?
Yes.
Yeah. So it's going to, as it enters a denser medium, it's going to bend towards the normal, okay? It's going to bend towards the normal. Let's say I use a white, so it's going to form, something like this. So that white part is going to be the part of the light.
Refracted ray.
Yes, refracted ray and angle of refraction. While this
I
will be your angle of incidence.
incident.
So if it's from the denser medium, let's say glass denser, and this is air, you know, it's from denser medium to less dense medium from glass to, so it's bending away from the normal this way. But if it's from less dense
Less
medium like
dense
air to whatever, so it's bending this way.
towards
So as it's bend away from the normal, so reverse, less dense medium to denser, the light will be attracted towards the normal. Okay,
it.
that's what we see in this one. So, which option do you think is correct now?
See,
C, right?
Yes.
Yeah, C is the correct option. Okay, let's see if we can look at one more question before we close for the day. Okay, let's look at this one.
then it's my
So, read this question and see if you can provide the solution.
See, ABCD. This because can give us speed. I never got to believe. We are 9.1.
So, have you seen an answer there? Okay, let's look at this quickly. Please, I want you all to concentrate because I'm going to ask you a question. Whenever you see, what does H stands for? Do you know? Do you know what H stands for?
Planck constant.
What do you call it?
Planck constant.
Planck's constant.
Blank. Yes.
Okay. Now, if we to get this, there is a formula that relates this Planck constant H with the wavelength and the momentum. So H equal to Planck constant over, I said H, lambda, which is the wavelength, equal to Planck constant over momentum. And your momentum is mass times velocity, okay? So the wavelength you are looking for now will be the Planck, what's the Planck constant given? 6.6 times 10 raised to
Six
power,
6. That's 4. That's 4.
yeah, times 10 raised to power 34, then over mass. What's the mass? 9.1
Plus
times 10 raised to
9.1
power
is
31.
31.
Then the speed 2.6,
So
oh, 2.0. That's 2 times 10 raised to power
it's
6. So what you simply do is 6.6 over 9.1 times 2, then
10.
times 10 raised to the power 34 minus 31 minus 6.
Or minus 6.
So now multiply this and 9.1 times 2 gives us 18.2. So 6.6 divided by 18.2, that will be 0.3626. Let's say 0.36. Uh, yeah, this is 0.3626 times 10 raised power. So you got to say 34 minus 31 minus 6, okay?
That's 3. That is minus 9.
Eh,
How much?
are you
Minus
sure?
3.
Minus 3,
Say
okay?
minus 3.
Minus 3.
Answer.
So this is finally 3.63 times 10 raised power minus 4 meters. So the options were mismatched. Okay, this minus 4, this minus 4 supposed to go to the any one of the 3.63. Okay, so that means the last option is supposed to be the answer. All of them are 3.63. So any one of them should have been the answer if it has the correct index here. Is that clear?
Yes.
So this is how to get
Yes,
that
sir.
done. And that is where we'll be rounding up the class for today. So by the grace of God, we're going to meet tomorrow. So goodbye for now.
English. Bye, enjoy your weekend.